Hey y'all, today we're going to be talking about infinite limits, specifically limits that equal infinity, and really ones where they're equaling infinity around their vertical asymptotes. So we're going to be looking at number one, so graph f of x is equal to 3 over x minus 2, and then we're going to find each of these limits and the values. Okay, so like I've said before, I don't want you to stress out about graphing these. Okay, it is bigger on bottom, so we have a horizontal asymptote at y equals 0. We also have that x minus 2 in the bottom, so we have a vertical asymptote at x equals 2. And it's a pretty standard rational function, so we should be in those sectors. Okay, if you don't know how to do those, as I said, you will not be expected to need to know how to graph for calculus. Graphing is a helpful skill. Okay, so you can always plug in values to the left and the right of the vertical asymptote to know if it's going to be above or below the horizontal asymptote, or you can just use a calculator and move on so you don't worry about graphing too much. So let's talk about some of these values. So f of 2. So if I plug 2 into this function, I get 3 divided by 0, which is undefined. That's not a number that we actually can get, which that matches up with what we know about what's happening on our graph, which is that we have a vertical asymptote there at x equals 2. So not only do we prove it algebraically, but we can also see it graphically. Okay, now let's talk about our left and right side limit. So our limit as x approaches 2 from the left side. So graphically, looking at our function, as we approach 2 from the left side, we're going to follow this left-sided curve. So as we follow from the left side, we can see that it's going down, down, down. What would be all the way down forever? It would be negative infinity. So I can already see that it's going to be equaling negative infinity. But how can I kind of understand that and see that algebraically? Because it's not always feasible to be able to graph. Well, let's just pick a number to the left of 2. So like if I wanted to plug in 1, which is just to the left of 2, so this would be 3 over 1 minus 2, which is equal to 3 over negative 1, which is equal to negative 3. So I picked a number to the left of 2, and I got a negative number. What that tells me is that my values, as I get closer and closer to that vertical asymptote of 2 from the left side, are going to be negative values, which means my function is going to be approaching negative infinity. And that holds true for all rational functions. So it's kind of a way that we can almost cheat a little bit with our rational functions, is we can just pick a number just to the left or just to the right, and it should usually give us enough information to be able to pick positive infinity or negative infinity. If you're ever not super confident in the number you picked, you can just go a little bit closer. So if I wanted to go closer than 1, we could do 1.5. So 3 over 1.5 minus 2 is equal to 3 over negative 0.5, which 3 divided by 1/2 is the same as times 2. So that would be negative 6. So you can see as we're getting closer, we're getting more negative. If we got infinitely close, we would get infinitely negative to be negative infinity. Okay, now looking at it from the right side, part C, as I approach from the right, should be sort of the same idea. So I can see it's going up towards positive infinity, but let's prove it algebraically. So a number just to the right of 2 would be 3. So 3 over 3 minus 2 would be equal to 3 over 1, which equals 3. Okay, so I got a positive number, so I know my limit should be positive infinity. Okay, I can go a little bit closer if I'm not super confident in that. So we can go 2.5, which equals 3 over 0.5, which equals positive 6. So you can see as we get closer and closer, we're getting higher positive numbers. So we would keep going up all the way towards positive infinity. Now for my overall limit, okay, is infinity and negative infinity the same thing? No. So we would say our overall limit does not exist. And in general, even if both of our rational functions are approaching the same infinity, so if they're both going up towards positive infinity or they're both going down towards negative infinity, the overall limit at a vertical asymptote is always d and e. Okay, because it's kind of weird to say like, well, they're both going up to infinity. It's like, yeah, but infinity is not really equal to infinity because it's an ever increasingly big number, so it can't really be equal. It's a long, complicated math thing, but just know, even if they're going towards the same infinity, the overall limit is still d and e. Okay, so I'm going to skip vertical asymptotes because I'm going to assume that y'all can find vertical asymptotes just like we did over there because we did it last year in pre-calculus with rational functions. But I'm going to do one other practice one over here. So we have 1 over x minus 1. Okay, we have a vertical asymptote going on there at x minus 1. So that's going to be at x equals 1. So we can graph that in here. And it is bigger on bottom because x is bigger than no x's. So our horizontal asymptote is y equals 0. And then once again, it is a pretty standard rational function. And it's positive, which means it's going to follow that same pattern as our standard rational function. But once again, you can plug a number in if you wanted to check. Or you can graph it on your graphing calculator to help you out. Okay. So now let's look at our limit. The limit as x approaches 1 from the left side. So what's a number just to the left of 1? Well, 0. So 1 over 0 minus 1 is equal to 1 over negative 1, which is equal to negative 1. So I got a negative number, which means my limit is going to be negative infinity. Okay. I will do one more. No, we'll do 5. Okay, so 5, we have the limit as x approaches 1 from the right side of 1 over x minus 1 squared. So even though I have x minus 1 squared, doesn't matter how many times the same factor is repeated, I can only get one vertical asymptote out of it. So x minus 1 gives me the vertical asymptote of x equals 1. So same vertical asymptote we had down here in the bottom. Okay. This x squared means it's x squared on the bottom versus no x on top, so it's bigger on bottom, so I get a horizontal asymptote at y equals 0. And then this one, fun thing that the squaring does is it moves both of them up to be positive. Because if I square any number, whether it's positive or negative, it's always going to be positive. Fun little math fact for you. Okay, now just looking at our graph, if we were to guess, what would we say our limit is as we approach from the right? Should be positive infinity. But let's put some numbers in to confirm that. So let's plug in 2, which is just to the right of 1. And I'm looking at my right-sided limit. So limit, wrong color, which I'm sure y'all don't really care about, but you know, color coordination is key. So 1 over 2 minus 1 squared is equal to 1 over 1 squared, which is just 1. So I got a positive number. So our limit is positive infinity. All right, go ahead and finish out the rest of these.